Hey guys, today we're going to be building the Y Combinator bots, and we are going to be using LangChain, which is a framework that provides interfaces for every model, tool, and database to help us build faster and also prototype. But we are going to also be using Pinecone as our vector DB to store our vector embedding, and also we're going to be using aiogram as an interface. Aiogram is just a framework built in Python to help us develop Telegram bots. So we're going to just jump into texting the Y Combinator bot. Basically, this gives you up-to-date information about any anything, any news you want to get from Y Combinator. So you can ask questions, different questions. When was the YC bot created? That was created in 2013. And you can ask any other question like, what is what is the YC safe? And it's gonna tell you what it is about. So you can ask how many co-founders are looking to be matched. You can ask how many co-founders are looking to be matched, and it's gonna give you the number actually. Um, or probably we can rephrase the question saying how many co-founders are looking for matching on the YC website. Right, website. Yeah, this is gonna give you around 16, which is the right number. So basically, this is how the bot works. It just gives you up-to-date information about anything you want to know, like any YC related question. You can ask about FAQs, when is the new cohorts accepting applicants and so forth. So basically, that's what we're gonna be building today. And what concerns the next step is gonna be done on the other side. So see it. So this is the fourth phase, which is the semantic search, and the fifth one is the retrieval. So after retrieving the the text or relevant results, we are going to go to the other phase, which is called augmentation. Augmentation is just comprised of the ranked result. The ranked result is the results gotten from our previous search. A prompt is just an instruction that you give to an LLM model to give you the right answer. In our case, this will be like, hey, you are a helpful assistant that asks questions about Y Combinator. So do not be concise. If you do not know the answer, just say I don't know. So once you give that type of instruction to a model, the model understands the exact thing you're looking for. So that is a prompt. So combining a prompt with the rank results and a question, we are going to go ahead and feed them to an LLM to get a human-like response. So this LLM is going to generate for us a response that is going to be sent to us. That's why we ask the question, what is the YC safe? It got the question got vectorized and then performed the semantic search and retrieve the ranked results down here. And then this ranked result has been combined with the prompt, which is our instructions, and the query, which is the question asked by the user and get fed to an LLM model to generate a human-like answer. And that answer was returned to us. So basically, this is all I can explain about our RAG pipeline, and I guess it's clear enough. And if you want this, I'll just put in the description below so you can get to play with it. So we're going to jump into the building stage and see you on the other side. So it all gonna start here where you have this Chatbot starter. You're gonna go ahead and grab this link and go to your editor of choice or IDE of choice and clone the repository. After cloning the repository, you are going to have such a setup. You have the experiment folder, holding the trials file, which is a notebook file, where you're going to be practicing or experimenting to make sure our RAG system works properly. We're going to have a source file, which is going to hold the init file, which is actually going to be our constructor, the helper file, which is going to hold all the reusable functions, and we're going to have the prompt file, which is going to hold our system prompt. Down here, we're going to have those environment variable file, which is going to hold all environment variables. And for me, I've already filled them up. I'll show you basically how to get them. The app file, which is going to hold the bot implementation, the requirement file, which holds all the required dependencies to run this app, and store index, which is going to hold all the implementation with our vector DB. We have to create our virtual environments, and the virtual environments are created by this command python 3-m vnv. So this is going to create our virtual environments. In my case, I've already created them. And then we're going to activate the virtual environment by running source vnv/bin/activate. So this activates our virtual environments, and after it's activated, that's when you're gonna see it here in your terminal. So after that, now you have to install all the dependencies. And this command pip install -r requirements.txt is the go-to. So you run there, mines are already satisfied, means already working or installed. Now we're going to go ahead and play around with our implementation in the trials on notebook file. Most of the time, it's going to ask you to select a kernel on your top right corner and install it here on the bottom left corner. So that will help you like run any code or statements here perfectly without any issues. Now what you're going to do is I already have most of the code base, right? I'm gonna be importing some code snippets to make sure we don't have a longer video. I'm gonna keep this shorter. I'm gonna be copying and explain everything to you. So at this point, we are going to need to import all dependencies that we need to build this rack system. We are going to get our system always touch and text wrapper from Python, which are built-in method, unstructured URL loader from LangChain documents loader, text character splitter or character text splitter from LangChain text splitter, OpenAI embedding from LangChain embedding, and Pinecone vector store from LangChain Pinecone. So I'm going to be explaining each and every one of them as we are going to be using them. For now, you're going to go ahead and run them. So, so the next lines of code are here. We're going to go ahead and download certain packages from NLTK. NLTK is just one of the dependencies that LangChain needs to extract the data. And we just get these two packages and we'll be good to go. So we're gonna run this command and that's gonna be it. Next, we are going to go ahead and add our URLs that we're going to be using. These are the URLs that we get from the Y Combinator websites. There are 12 and they grab different informations or data from the given pages that they are specifically talk about. So we're going to add these URLs here and store them in URL. So next we're going to create a function, our first function. If you remember from our RAG pipeline, we start by processing the preparation and processing, which is loading data and extracting documents from the unstructured data. So we are going to use the unstructured URL loader, which we imported here on top from LangChain documents loaders to to load unstructured data and also go ahead and extract documents out of them. So this function works perfectly. Remember the name is load data. The next function is gonna be split text. The split text is just gonna go ahead and implement the second step of our rack system, which is chunking. So I'm gonna grab this function and paste it here. Split document is just utilizing the dependency or the class character text splitter that we imported on top here from our LangChain.text splitter. So we just create an instance of it and pass these arguments. So you can find this even from the documentation. But for you to pass the arguments, the first one should be which kind of separator you want and the chunk size. Remember, I put in the chunk size because the limit chunk size of OpenAI is around 4,000. So, but in our case, we just want to go ahead and use 1,000, and the chunk overlap is going to be 200. So why are we putting a chunk overlap? It's because we don't want every chunk of text to lose context. So it's gonna be like we have 1,000 here and 200 here for the next. So the next chunk is gonna be grabbing 200 from the previous chunk to not lose context. So we created our splitter here and called the split documents by passing the documents that we have loaded in our previous function here, and it will be good to get the text chunks. So the function worked perfectly, and we can go ahead and try this to make sure they work perfectly. So we're going to split the text, and we're going to see how much we have, how much of the data we have. So basically, I'll go ahead and do this. The first function calls the load data. The second one splits it. So we're gonna get the chunks and the length of the chunks. So we have 51 chunks of size one of chunk size 1000. So you understand that all the operations are going perfectly. So we're gonna go ahead and create our indexer. First of all, we have to load the environment variables. So by importing .env from load.env and calling this function, we'll be able to load them. And now I have to show you where I got all of these environment variables from. So we're going to go to platform.openai um, .com for to get the OpenAI API key. We're going to go on Telegram and create a bot. We're going to go to Pinecone. We're gonna create an account and go ahead and get an API key. So I'm gonna go ahead and do a couple scrolls. For you to get an API key, you have to create an account and go to your settings or dashboard and come here to open to API keys and create your key. After creating your key, you're gonna grab the details. You're gonna give it a name, of course, and you're gonna grab it. You're gonna grab that key and go ahead and paste it in your environment variable. Now, to get the Open API key, so if you have already created your account, you're going to come here and just click create keys or secret keys, and you can pass the name and organization, and that will be it for you. You'll have all the two first API keys. So we're going to go on Telegram. We're gonna look for bot father here. We're gonna go on bot father, and what you're gonna do is we're gonna put slash new bots. It's gonna ask us to choose a name for our bots. You have to give a name. We're going to also give a username, which might be of these types, either one of those. And I've given mine. After giving after giving the username, it's gonna create your bot and it's gonna give you the uh Telegram token API. So this is what you are going to come and place here in your environment variable. So you're gonna have the three of them. So now that we have all the environment variables in our file here, we are going to load them, and we already did it here by running this command. So the next step is just gonna be creating a what? Creating a function that is called load embedding model. So that function is basically gonna hold it's basically gonna call, it's gonna just load our embedding model, and that's it. So to have this up and running, we just call this OpenAI embedding, which is one of the dependencies again we got here from LangChain.embedding, and this is gonna set us ready for the next of the thing. So if you wanna try how the embedding works, you can just go ahead and try some tests with it and just make sure it's perfect. So at the end of the day, you need also a couple of things here to make sure you don't it does not crash. So first of all, you have to import OS and get these environments variables. After getting them right there, this is gonna set you well when you're trying to play around with the embedding mode or trying to see even which LLM mode are we using for this. So you can go ahead and create a question and call embedding, like load embedding. I'll go ahead and say embedding, embeddings. I'll call that function. This is gonna, and then I'm gonna have my question here. What is the purpose of Y Combinator? And I'm gonna embed it so I can see how the vectors look like. So see, this question's representation in numerical value is like this. So every vector embedding is already something like this, is numerical value. So they're just represented in numbers. So at this point, we haven't checked which model we are using, which we can do right here. And this is gonna be either 002. Yes, this is the default embedding model that we use. So now it's time to create our Pinecone database. And you know we have to import some specific stuff or specific dependencies. So from Pinecone grcp grpc, I'm sorry, we are going to import Pinecone. A Pinecone grpc is Pinecone, and from Pinecone we are going to import this serverless spec, and we're going to import again OS, which we don't necessarily need because we already did it on top here, right? So after this, we can run these imports. They are good because we already installed those dependencies. Now we are going to go ahead and create our Pinecone. So I'm gonna copy paste something that I found from the documentation. I just added our index name. So you just create an instance of Pinecone and you pass in the Pinecone API key. Remember we loaded it on top here. After doing that, you create your index name and now call the function create index and pass the index name, the dimension, matrix, and specs. So all of these are just being copied from the documentation. How do you get the index size? So the index size is gotten here actually. After getting this embedding, you can go ahead and print it to get the dimension. I'm sorry. You can get the dimension, and here is gonna be, let's store this in trial. So by having the print statement, by storing this embedding in a variable or assigning to a variable, we can put its length to get the dimension. So the dimension is 1536. And if you go down here, that's why we pass this dimension. At this point, we have already created our index. We can go ahead and check it on Pinecone. We already have the chatbot right here. Now we are going to go ahead and abstract this index. So this is gonna go ahead and abstract each of our chunk into our index, the Pinecone index. And now if we go back to Pinecone, we have our index here, and we can check the index. It has the 51 chunks. Remember we did this already. So what is the next step? In the Pinecone documentation, I found this. This is the way we can load the Pinecone index that already exists. It's just calling the function from existing on Pinecone vector store and pass the index name and the embedding. So this help us load the already existing index. So next to that, we are going to create a retriever. Remember I told you that we are going to get top or ranked results. So that's what we're going to be doing. So we just call this vector on our vector DB. We call the function as retriever and we pass the following arguments. The first one is the search tab. We're performing a search tab based on similarity. And again, we have the search queue arguments and we are going to have K3, which means we are going to return the top three only. So we're going to create this retriever here. I'm going to call the function invoke on the retriever and pass in my question. And once I run that, it should be ready to go. Now, if I want to print this answer, it's going to be a bunch of documents. So I can go ahead and print it here down. And you can see it's a bunch of documents. It's the top three. If I need a top two, I can go ahead and say, does I need a top two? And I ask the question, and now I'm gonna get the top two, but I need the top three. So this is it, and I'll do there, and I'll go down here, and I'm good to go. So basically, that's how it works. You retrieve the document, you retrieve the rank documents according to the number that you give here, and based on any search of your choice that you might choose. So that's it. We have already loaded our documents or the retrieved documents like that. We are going to now load the model. We import OpenAI from LangChain OpenAI and uh, pass the temperature, pass the arguments temperature of zero point 0.4 and a maximum token of 500. So I guess everybody knows the temperature is just as long as it's close to zero, it means it's gonna be more exact to your prompt. And when it's close to one, it means it's gonna be risky and creative. So we load that model here. The second step that follows this augmentation phase is creating our prompt. So the prompt is gonna be created this way. I'm going to import create retriever chain and create staff documents chain, chat prompts templates, and then we are going to go ahead and create our variable name consistent prompt and pass our instruction here. In our case, it's just your helpful assistants that answer questions about YC. Use the following pieces of retrieve context to answer the question. If you do not know the answer, say that you don't know. Use the three sentences maximum and keep the answer must be in a markdown format and keep the answer concise. That's what I wanted to say. So here we're passing the context. And now here's where we are creating our prompt. So we just call the function from message on this prompt template, which we imported here from LangChain.prompt. And we're gonna pass the system. The system is just gonna hold the system prompt, and the human is going to be the input value. So when we run this, we are already good with our prompt. Now we are going to go to the creation of question answer chain and the rag chain. So you can grab this from the documentation. It's also pretty clear. So what we do is we call the function create chain stuff and we pass the LLM which we loaded on top here, remember, and give the temperature, and we're gonna give also the prompt that's gonna create our question answer tag. And now for us to create the rag chain, the one that we're gonna be evoking question on, we have to create a retrieval chain. So this retriever chain needs two arguments. It's the retriever that we pass here. Remember, it's gonna retrieve the top three. It's here based on similarity. And then we are also gonna pass the question answer chain in there. So once you call this, you are going to be good to go. Now you can ask a question and get the answer. So let me copy paste something from my code snippet to save time. And right now we can ask the question by calling the function invoke on the right chain and put our inputs here and ask the question. So you can say, what are the world class founders on the co-founder matching? So this is one of the questions they are really on the website of YC as Solak. Something like has some guy buddy from Harvard, somebody who is the youngest engineer to get promoted, people work with Visa. Yes, this is it. I saw it's on the website. So this is already working good. So how many co-founders? How many co-founders? How many founders are in YC? If he has these concepts, okay, we have about 1.5K. Why? Okay, when is the new batch starting? I'm just playing around. When is the deadline? Is the next YC demo day? I guess it's gonna give us the most recent one. It'll be on Tuesday, 9th September. Yeah, that's the one that happens like is it yesterday or something? Yeah, so it actually gives you relevant information about YC, like they are up to date. So we're going to go ahead and create our real application. So this is going to be a little bit different. We're going to go ahead and start by taking all the functions that are here and put them in our helper. So before we do that, we first of all gonna go ahead and import every needed dependencies in our helpers. And we know we're going to be using split embedding. We're going to be getting that function. We're gonna go another function which is load the API model, load the large language model, which is just loading the large language model that's gonna be used here. So this is gonna be transformed into a function as well. So I'll be going back here and place these here. These are the dependencies that we need to just get this going. And I'll grab all of the functions that we need from here. Um, which functions do we need? We need this function, the load data, we need this split, and we'll create this as a function. Thus, what is it? This one. So, and we're going to come here and paste them here. So as you can see, now we have three functions: load data, splits, and load large language model or embeddings. This function is going to be used in our app. So what do we do next? If you check our, after after loading the embedding model, creating the embedding, we're going ahead and create our Pinecone database. So the Pinecone database implementation is going to happen here. And what we need to deal with the store. So what we need to deal with the store is we need first of all the main dependencies, and the main dependencies include um, these ones here. Actually, we need these dependencies. We need to load the environment variable. We need to load the Pinecone API key. We need these URLs. All of them are being grabbed from here. And we need to load, uh, now we are calling the function load URL because we have imported here from the helper. We imported the three functions, the vector, the serverless specifications, and also the Pinecone um grpc. So, and we have our urls here. We feed them here. We load we call the function load data to just go ahead, load unstructured data and retain documents. And then those documents, we are going to pass them in the split chunk, split documents to get the text chunks. And then we load our embedding, but also put here the bot's name. So our bot name is right here. So I'm gonna make sure it's the same so we don't lose. Okay. So now we have a Pinecone, right? We have to create a Pinecone instance by passing the API in here. So we're gonna get a Pinecone index and use it to create now to create an index, a Pinecone index. So we are going to pass the index name, the dimension. The dimension we got it from our trials. These are just documentations from the Pinecone documentation website. So this can help us create a function again. This help us insert the data or upsets the embeddings into our Pinecone index. And that's gonna be it. So the first thing that you're gonna be doing is say it's okay. You're gonna go ahead and remove this or delete it. So after deleting the index, make sure it's completely deleted. We're gonna go back here in our code base and we're gonna say Python 3 and it should run that stuff. It's saying you cannot open this. Of course, yes, because it's out of this. We can place it out. We placed that file out. My bad, I mistakenly put it inside. And now once we run this, you can see it creates the PyCache and it's running our query here trying to create the Pinecone DB or index on the Pinecone server. So once it's done here, we will go on the other side and check. So a little bit of time. If we refresh here, we can probably see it's already here, but it doesn't have anything because it's still trying to initialize it. So we can go back here and wait until it's done initializing and we'll be good to go. All right, it's completed. Now we can go ahead and check back here. If we load this, we're going to see all the 51 vector embeddings here already recorded or stored in our index. So basically, all of these works the initial part of it. Now we're going to go ahead. I've already created these bolts and I'm just gonna walk you through the codes base because I don't want to make this tutorial longer. I just want to make it as short as possible so we can know how to accommodate the other stuff that we have to do. So I'll place this in and I'll explain whatever we're doing. So basically we are importing all of these part of the documentation. The documentation says we should import the default bot property, the parser mode, the command stats, the command, the message, the bot, the dispatcher, the HTML, and also going down here, we should also go ahead and import our normal files that we already have here. Basically, we're gonna import the .env file, and we're going to import the embeddings from our helper file. We are going to import the prompt from our prompt file. I actually haven't created a prompt yet, so I have to put here our prompt dot python, and this is gonna be just our prompt. So we're gonna grab that prompt that we created, the system prompt, from here. What is it? It's down here, and we're gonna put it in here. So this makes us eligible to code properly, because you can see that it has disappeared. So we import the prompt, the system prompt. We import OpenAI. We import Pinecone vectors. We import create virtual chain, and we import create stuff documents chain. We import chat template and async login OS system. So we start by loading the environment variable and access them here, all of them. And now we're just gonna do whatever we've been doing with our Pinecone notebook. Here we're loading the vector DB. We are also getting our embedding. We create a retriever to get the top three. We have already gone through this. Now we're going to create our prompt template. We are going to pass the prompt system. The prompt system is the prompt system that we have here. Basically, this is already what we have done. So we have the question chain, which asks us to just create a stuff, call the stuff, call create stuff documents chain, and pass the LLM and the prompt to get the question answer chain. And to get the RAG chain, we have to call the function create retriever chain and pass the retriever. I'm creating this class. The class is called reference. And this class is to store previous response from the ChatGPT OpenAPI. And here's three three functions. The first one is the constructor. The second one is add reference and get reference. So basically, that's what it does. And here we are creating an instance of it. Now, all bots should be attached to a router, and that's what we are doing here. So here, comment stats handler. This is straight from the documentation. By passing this decorator here, it will help us to start the bot. So once somebody goes to slash start command, what's gonna be done is we are going to greet him by saying hello, call the HTML as a bold, and get the message and get what the user's name, the user's full name, and do it. That's why if you remember the demo, when I just click start, it greeted me. So this clear is just gonna clear the previous conversation in the chat OpenAI chat memory. So, and this function help is a function when you're trying to just get help to know more of other functionalities that the bots can do. Once you go under slash clear, this is what happened. It calls the chat GPT a reference and set it to empty. The function RAG message just handles the message from the user and sends it to the RAG system. So we already have our decorator here, which is gonna help us grab the message from the user. And then here we're going to call our invoke. This is the fun. I guess everybody's familiar with this. We call the chain RAG chain dot invoke and pass the user's message in here, get the response. We can print the response and say it, but also we can go ahead and do this and say and add it to the reference, to our chat reference, so we can chat back and check. So at this point also, we're going to go ahead and send that response to the user in the chat. So if we found an error, we just respond with the following message. So now this is the main function. This is just initialize the bot. We get a bot token, we place the default. That's why we had all of these imported these dependencies. So basically, this is something you grab from the documentation. It just helps you initialize the bot and passing the right parameters, and then you're gonna go ahead and ensure the what's the webhook is removed before starting the polling to avoid conflict. So this is something you just grab from the documentation, and this is how the bot is getting run. So now if we go ahead and run our bots, let me grab python.py again, put it here. Oh, it's telling me about the framework version, blah blah blah, not certified. Put it here as well. So I have the pie right there. This is gonna allow me to launch the bot. Wow, wow, wow. So we're going to load it back and see. Now it works perfectly. We have loaded our and we have started polling. So as we start polling, our chatbot is ready and you can see the username of it. So pretty good. Everything is good. At this point, we have to just go back and go to this chatbot. Now, once we start, it's gonna greet us. Hey, Guardian. Okay. I can grab some like that and test. When was the demo day? Tuesday 9th September. Or what is the YC save? I can go like that. When was the YC save introduced? Okay, how many companies does YC have? I hope we have completed this build. We also have a blog that where I post all of these tabs. Basically, be sure to check it out as well. So I'm gonna leave the link right here to just show you my Medium account. So you can go ahead. You're gonna find the blog, a step-by-step blog explaining this. That's gonna be here. Be sure to come here, clap or follow. Let's grow this to 100. So yep, that's thank you for joining me today, and hopefully this build has changed a lot. And see you in the next one. Guardian Cards.